Hello everyone, welcome to today's statistics lessons. In this session, we will work through a classic statistics questions about conditional expectation and probability. These problems comes from the past exam at the university, and let's try in and break down the questions step by step to understand how to solve it. So let's review the question. We have two random variable x and y, and with a drawing probability density function. So the function is defined as when both x and y are uh, are between zeros and one, and x is less than or equal to y. The probability density is 2 here. So this is a probability density. So otherwise, the probability density is 0 here. Okay. We have two questions. So first, we need to find out the expectation of the product of x and y, which is called e of x times y. So, and then we need to find the conditional probability function of x given y, as well as the conditional expectation of x given y. So, first of all, we need to understand the question first. Before solving, let's clarify what each part means. The first part, the first one, we need to calculation the expected value of x times y. Essentially, this means find the average value of x times y across all possible value within the specified range according to the given probability density. So, for the part two, we are asked to find the conditional probability of x given y. So this tells us the probability density distribution of x if we already know the value of y. Then we will calculate the conditional expectation, which is the average y of x under the conditional that y is fixed. So okay, so we create the question. Now we start to do the question C. So part C is to find the expectation x of expectation e of x times y. So before we calculate this, the expectation e of x times y, we need to draw the diagram more easy to understand what this is. So because here we're talking about x is the value of x is between y and 0, and the value of y is between 1 and 0. So I can draw the graph like that, so that something like that. This is y-axis, this is x-axis, because y is less and equal to 1. So if we here is 1 here, okay, the maximum value is 1 1, because here x is equal y. So we want to find the area is this here, this area. Okay, so now it's clear. You want to find this area. So this is mean. So for this graph, we need to understand what's the meaning of expectation e of x times y. Okay. So and then it means we involving integrating 2 times x times y. So first with respect to x from 0 to y. Okay. So it's something like that. So the outside integrate is 0 from 1 because it's y. Okay. And then in the and inside the integrand is 0 to y because this is for the x. So the density probability density here is 2. So and then you need to put the xy here, and then this is for the integrand x, this is for the integrand y. Okay, so we solve this question first. So this is easy. It's integrate here 1. Sorry, this is y. This is y 0, and then dy. Okay, so we substitute the y. So we got this result, this got this, right? And then because y is from 0 to 1, we substitute 1 into, because this formula can equal to, after integrate, is equal to 1 over 4 times 4 power of 4. And then the value is from 0 to 1. And then when we substitute a 1 value into, we will got 1 over 4 here. Okay, so this is the answer of the question C. And about the question D, so before doing the question D, we need to write down the condition definition of marginal definition of conditional probability. So we need to find this one first, right? Here we will find the conditional probability function first is equal to f x y divided by fy. Okay, so fxy here, fxy, we know that this is 2, right? This is 2 because here it mentioned that it's 2. So we need to find this one, right? We need to find this one. What is this? Actually, uh, mm, this is marginal density function. So fy is uh, is marginal density function. So first of all, we have to understand the definition of marginal density function is Sy equal to negative infinity to infinity x fxy divided x. So here where the y is vectors variable value is vectors, y is vectors here. So since the fxy is a non-zero, so only the range is 0. Only the range is less than 0 and smaller than x, and y is not and equal to x. This is the range. So we can adjust the limit of the integration accordingly from this. Okay, this y 0 f s fxy and the dx. So and then we need to substitute f xy equal to x into the integrate. Okay, so finally we got that. And the integrants 2 with respect to x. So we got here, and it's easy. And if one that the x y 0, yeah. Okay. So finally we got that. Okay, it's 2y. Oh, so now we know that f, therefore fxy equal to f, sorry, function of x dependence of probability density of x given by is given by is equal to fxy divided by marginal density function fy equal to 2 divided by 2y equal to 1 over y. Okay, so we can do the d now. So the d is expected value expectation of expectation x given by y. So x here. So we can put this is x, right? And then this is a conditional probability. And then because we already know this probability a conditional probability function is equal fx given by y is equal to 1 over 5. So that this is I can transfer something like that. Okay, so this is straightforward. Next to and then is 1 over is y over 2. Okay, so we calculated the expected station of x times y as one yeah 1 over 4 here. Okay, and then we derived the conditional probability function x given y as a 1 divided by y here, and then and then and then we found that the conditional expectation of x given y is divided by 2 is y divided by 2. So these problems help us understand the dry distribution and conditional probability and expectation, which are fundamental concepts in the statistics. So by break down each part and work through the step by step, you can see how these calculations give insight into the relation between the random variable. So thank you for joining me today. I hope this workflow helped you understand how to solve the problem involving joy distribution and conditional expectation. So keep practice and remember that tackling these problems step by step make them much more manageable. So see you in the next session. So this video should let you create to understand how to calculation the conditional probability function. Okay, see you later. Bye bye.